Welcome back, everyone. Are you concerned about the security of your valuable data in the cloud? Join me for this impactful presentation on cloud security, where we will dive into the key security considerations in cloud computing and share best practices for ensuring robust data protection. Discover the latest technologies and strategies to safeguard your sensitive information, mitigate risk, and fortify your cloud infrastructure. Don't miss this opportunity to gain valuable insights and empower yourself and your organization with the knowledge to protect your data. Together, let's unlock the potential of the cloud while keeping security at the forefront. Join me today for this wonderful presentation. As a part of the cloud security essential, we split this presentation into two parts, one for the best practices, another one is security considerations in the cloud computing world. Cloud security, as organizations continue to embrace cloud computing, to enhance their operations and optimize efficiency, it is crucial to understand the key security considerations and best practices that ensure protections of your valuable data. As I stated earlier, this presentation is basically packed with 7 different videos into two main components. One for the security consideration, which is a very fundamental part of the cloud security. Another one is the best practices around the cloud security elements. If you look at the data security considerations, there are 5 major components: data protection, access control, identity and access management, in other words, IAM. Fourth one is network security, and finally, data backup and disaster recovery. Let's dive into the data protection. Data protection. The protection of your data is of the paramount of importance in the cloud. Organizations must ensure that their data is fully encrypted both in transit and at rest. Encryption helps safeguard sensitive information from unauthorized access even it falls into the wrong hands. Data protection plays a vital role in securing the security and privacy of your data in the cloud computing. As a part of the data encryption, the very first option is symmetric encryption. This is the fundamental process flow or architectural part of symmetric encryption. Symmetric encryption, also known as secret key encryption, it uses a single key for both encryption and decryption. This key is shared between the sender and the recipient. Symmetric encryption is fast and efficient, making it suitable for encrypting large amount of data. However, the challenge lies in the securely sharing and managing the encryption keys. Asymmetric encryption. Unlike symmetric encryption, asymmetric encryption, it deals with two different keys. It's also known as public key encryption, employs a pair of keys, a public key and a private key. A public key is used for the encryption while the private key is used for decryption. With this approach, anyone can encrypt the data using the recipient's public key, but only the recipient with the private key can decrypt it. Asymmetric encryption provides a secure method for key exchange and widely used for secure communications in the cloud environment. Third one is hash functions. Hash functions are one-way encryption techniques. that produce a fixed size output known as hash value or message digest. Hash functions are commonly used to verify data integrity and ensure that the transmission or the transmitted data or stored data has not been tampered with. Even a slight change in the input data will produce a completely different hash value. This is the process flow. Left hand side you see the plain text data is being sent across using a cloud network, and the hashing algorithm will convert into the hash text based on the hash function. Fourth one is a transport layer security, TLS, and secure socket layers, SSL. TLS and SSL are cryptographic protocols that provide secure communication over the internet. They use a combination of symmetric and asymmetric encryption techniques to establish a secure and encrypted connection between the client and the server. The TLS and SSL are commonly used in cloud computing to secure data transmission between users and cloud services. The fifth one is very important technology in terms of data encryption is homomorphic encryption. It's an advanced encryption technique that allows computations to be performed on encrypted data without decrypting it. It's a phenomenal technology. This means the data can remain encrypted even while performing the operations on it. Offering enhanced security and privacy, homomorphic encryption is still an area of active research and development but holds greater promise for securing the transmit in the cloud computing world. What you see here is the data transmission part and the receiving part of it. While transmitting the data is being encrypted, and during the encryption process itself, the data functions or data processing is happening, and the recipient receives the data using the homomorphic encryption technology. Key management is a critical aspect of managing and maintaining the security of encrypted data. It involves generations of the key and storing the key, distributing the key, rotations, revocations, access control, audit and monitoring, disaster recovery, compliance, and governance. If you look at the key generation, the cryptographic keys are generated using the algorithm designed to create strong and random keys. Number two, the key storage is safely storing cryptographic keys is essential to prevent unauthorized access. The key storage can involve various methods including hardware security modules. Key distribution: when encrypting data for secure communication or storage, keys needs to be securely shared with authorized parties. Key rotation: regular key rotation is recommended to maintain security over the period of time. Revocation: in situations where a key is compromised or no longer needed, it is crucial to revoke or retire the key. Revocation ensures that a key cannot be used to access encrypted data. Access control: implementing proper access control is essential to restrict key usage to authorized personnel or systems. Key auditing and monitoring: regular auditing and monitoring of key usage and management activities help identify any suspicious or unauthorized activities. Disaster recovery and key backups: having a robust backup and recovery strategy is critical for key management. Backing up keys and restoring them securely ensures that can be restored in the event of a disaster. And finally, compliance and governance. Organizations must adhere to relevant industry regulations and compliance standards concerning key management practices. So, effective key management is fundamental to ensuring the confidentiality and integrity of encrypted data. By implementing strong key management practices, organizations can maintain control over their encrypted keys, mitigate the risk of unauthorized access. Last but not least, bring your own key is a cloud security model that allows organizations to generate and manage their encryption keys. With BYOK in short, organizations can maintain control over their encryption keys, ensuring that cloud provider cannot access their data without organization's authorization. Finally, transport data encryption. Transport data encryption is a technique that encrypts data addressed in the database or storage system without requiring changes to the application. I hope this overview of data encryption types and techniques in the cloud computing was very insightful to you. If you do have more questions about cloud security and data protections, feel free to reach us at 1855 Cloud 340B or email at us contact us at rctech.org. If you like this video, please like it, share, comment it, ask questions. Please forward it to your friends. Don't forget to subscribe to the channel. Thanks for watching.